we have an extinction level event. The configurations, our DNA configurations have been switched with a DNA, a reverse transcriptase called 88 from the skinheads 88. And it's being used by a lot of fascists and a lot of fascist programmers and fascist hackers and fascist cracks to reprogram their food supplies and their assets and valuable documents and properties and premises back into their hands by using those programs to as their doorbells, as their door numbers. And 88 is actually the periodic table number of radium. So radium has been switched into a fascist symbol of power, and radium is now being used in that sense. Is being misused in the sense that one cannot look beyond the screen and know how radium is being used. One can only see it at the number of products that are being produced in the name of the 88, that they don't correspond to radium's properties, chemical properties. Radium, which is actually a stable isotope, has been turned into an unstable isotope in many German internets, and the food that is being produced is not as clean as it should be, because it causes isotopic changes in both organic and non-organic compounds like human beings and animals and plastics. It can and it is actually a very stable element from the sun, from solar radium, so that the radius of the radium has been minimized to serve a few people and at the expense, at the cost of the rest of humanity. And that's why we are trying to change that stable element back into the hands of the professionals who know how to use this periodic table chronologically, alphabetically, and with calendars to produce products and to produce food products and other products that human beings use without harming humanity. Because radium also means melanosis. If one doesn't take care of it, it can begin with mutating the melanin. It can mutate the calcium, vitamin D. It can mutate the kidney. It can mutate any other elements, and it is being felt a lot in the melanin functions and in vitamin D functions and in the calcium process too. And from tocopherol through the kidneys, or vitamin D is processed through the skin or through the gut to the intestines into the kidneys, and then processed into the final vitamin that is supposed to help human beings. It is also affecting a lot of the fascist community, which is using it as a symbol of health. It is devastating their organs quite visibly. Their organs are flying around. One can imagine when one sees them. It is like drinking pure radium on an empty stomach after watching TV or listening to the radio. It is like drinking pure radium, like drinking pure petroleum, like drinking not boiling petroleum, like drinking like a plastic can drinking hot petroleum on a hot day, or on a hot day, because all the other ions, all the other elements that help to homogenize the human structure are automatically put out of function by the rapid change of programs. Like when one uses a remote control, by the rapid change of programs, it causes all messages that are sent to human beings by telepathy, by telekinetic, by teleportation. They miss their target by a mile. It is a milestone for the fascists, but a great fall for all medics and all people of the medical branch, all gastronomists, all gastroenterologists, all urologists, all neurologists, all internists, all general physicians, all pediatricians, all gynecologists, all obstetricians, all midwives, because what comes up are children who look like they are viable to survive the amount of traffic that arrives with radium and radioactivity, like radios and televisions and other telecommunication and mass devices, but they cannot survive it if they have elements that oppose or that cause the radium to decay into its radioactive elements of plutonium and polonium and uranium. Because uranium is more stable than plutonium, but it doesn't mean that it cannot decay very fast into plutonium, depending by the amount of explosion that a gamma ray oscilloscope, like a cathode ray oscilloscope, hits an object that is susceptible to radioactivity, like a human object observing or watching a television, or a radio listener, a human being listening to the radio, other close listening to the messages and obeying the instructions, so that it is going to clash a lot with the instructions implementation manuals of radium, and it is going to destroy a lot of cause a lot of mitotic mutations in the concerned parties. Some of the most spectacular advanced isotopes in biochemistry, chapter 11. Some of the most spectacular advances in biochemistry have stemmed from the application of isotopes to the study of metabolic processes, a technique which gained impetus after the Second World War due to the rapidly increasing commercial availability of suitable isotopes. Compounds have been labeled or tagged by the incorporation of either stable or radioactive isotopes into their molecules, and then the subsequent fate of the molecules studied by tracing the movements of the labeled atoms. A major use of labeled compounds has been like radium-88. The major use of labeled compounds has been to follow metabolic pathways, like following the number 88 on any supermarket list, or any hospital list, or any chemical factory or chemical industry, chemicals producing or pharmaceuticals producing industry list, how the radium is labeled and how it is utilized efficiently or inefficiently or hazardously, or not at all. The major use of the labeled compounds has been to follow metabolic pathways. The appearance of the labeling is some isolated product of a metabolic sequence, and the determination of its position in the molecule by suitable degradative procedures has afforded evidence of the existence of certain pathways. The feeding of labeled compounds and their incorporation in the animal body has demonstrated that bodily components are not necessarily inert simply because their concentration remains constant. The classical researches of Schonheimer and Rittenberg paved the way to the concept of dynamic equilibria in the body tissues. Isotopes have also been used to determine the rates of reactions in living organisms, where despite the constancy of the concentration of the bodily components, continual metabolic activity turnover occurs and can be measured by certain isotopic techniques. They are particularly valuable too in the investigation of the kinetics of transport of molecules or ions across membranes. Selected aspects of the theoretical background to isotopic tracer work will now be considered. Stable isotopes, radium-88, the atomic number of an atom, i.e. the atomic number of an atom, i.e. the number of protons in the nucleus, determines its chemical properties. Almost all known elements exist as mixtures of atoms having two or more different atomic weights. Such atoms having identical atomic number but different atomic mass are termed isotopes of the element. Any sample of the element consists of a mixture of isotopes, and the observed chemical atomic weight is therefore the average weight of the mixture of different atoms, and depends upon the abundance of each isotope in nature. Thus, chlorine has isotopes of mass 35 and 37 in such proportion that the determined atomic weight is almost 35.5, and carbon consists of isotopes of mass 12 and 13 in the proportion of 99.3 to 0.7. Isotopes have also almost identical chemical properties that may often be separated by difference in physical properties, such as rates of diffusion and evaporation. In the case of deuterium, the isotope of hydrogen with mass 2, the situation is very favorable because it has a mass of 100% greater than the hydrogen, and heavy water D2 or may actually be estimated by the difference in its density compared with ordinary water. If by a suitable enrichment process the proportion of one or less abundant isotopes of an element can be increased, then a labeled element is produced, and compounds containing the element will similarly be labeled. Alteration of the natural abundance ratio is achieved by the same physical techniques that are used for the separation of the isotopes, and of this fractional distillation and electrolysis are the main methods used. The determination of the amounts of stable isotopes present in an element necessitates use of the mass spectrometer for all cases excepting deuterium. The mass spectrometer produces a beam of rays of positively charged gaseous ions of homogeneous energy. By the application of the electrostatic and magnetic fields, these ions are separated according to their mass, which determines the trajectory. An electrometer guided by a slit constitutes the measuring device. Application of a potential causes the mass spectra produced to traverse the slit, and each ion beam in turn enters the electrometer, where the ionization current is measured. Information is thereby obtained as to the amount of the element of a particular mass present. It is on this type of determination that the use of stable isotopes in biochemistry depends. The abundance of the labeling isotope as compared with the normal abundance in the labeled starting material and in the product of the reaction is measured. The degree of labeling of a compound is always indicated by the atom percent excess. If an element normally contains Y atoms of a particle, say heavy isotope per 100 atoms of the element, then there will be 100 minus Y atoms of the other isotope or isotopes, and the normal abundance is Y atom percent. Suppose that this abundance is increased to Z atom percent in the process of labeling. The difference between the original normal abundance Z minus Y is stamped the atom percent excess of the heavy isotope. Suppose that during the course of an experiment, the labeled material is diluted n times with the element possessing the normal abundance ratio. For every 100 atoms of labeled element, there will be a total of 100 n atoms of the element. Of these, Z atoms of the heavy isotope are derived from the enriched material, and Y into n minus 1 atoms of the heavy isotope are derived from the diluting material. The resultant element therefore contains Z plus Y into brackets n minus 1 atoms of heavy isotope in a total of 100 n atoms, i.e. Z plus Y in brackets Z plus Y in brackets n minus 1 close brackets over n atom percent, and the atom percent excess of the isotope is Z plus Y open the brackets n minus 1 close the brackets over n minus Y is equals to Z minus Y over n. Since Z minus Y was the atom percent excess of the starting material, comparison of the atom percent excess of starting and final material gives a measure of the dilution factor n. The use of stable isotopes of likely base are superseded by radioactive ones. Wherever there is a choice between the two on the account of the easier methods of measurements and the greater sensitivity. In the case of nitrogen and oxygen, no suitable radioactive isotopes exist, and the stable isotopes 15N and 18O are used. Stable isotopes possess the advantage that they are permanent and do not disintegrate with time, and furthermore produce no radiation effects on the tissues. Combination of both stable and radioactive isotopes permits the double labeling of a molecule, so that, for example, 2 different carbon atoms of a molecule may be labeled with stable 13C and radioactive 14C respectively. Radioactive isotopes. Radioactive isotopes for tracer studies may be prepared artificially from non-radioactive elements by means of either the cyclotron or the atomic pile, or the gamma ray oscilloscope with the RGB red, green, blue, red, green, blue, or the red, green, blue ions, red, green, blue gamma ray oscilloscope, or the cathode ray oscilloscope with gamma rays, X-rays, or alpha rays. But the alpha rays would diverge, will be deflected a short distance from the target and will not meet the target, or will need a lot of targets to extrapolate the direction and the target to be met at an efficient momentum and velocity. And the gamma rays will be straight, and the beta rays will deflect at a higher will make a higher deflection from the focus from the initial vector, a bigger deflection, and the beta rays will also be expected a short distance from the spectrometer, or from the person using the instrument, so that one will have to protect himself from alpha and beta rays too. The gamma rays would, on the other hand, not be deflected and would travel at the same distance, at the same velocity, would cover the same distance at the same velocity in a given time, and would not need the Newton's second law of motion. The only exemption will be if the target is at a vector not in the same line of the momentum of the object. That means that a new object has to be calibrated of changing the direction. That means that the momentum has to be deflected with the second mirror of the with the second force of Newton, and that will be a second either a deflector planes, or many deflector planes of the initial object, or with a second cathode ray oscilloscope to complete the cycle, and to complete the projector's calculated distance, velocity, and loss of momentum to reach a stop at the expected object, be it internally or externally, using big or small decoys of the same object on a table or on the floor. In this manner, considerable quantities of radioactive isotopes have been made available for biochemical and medical research. Radioactive isotopes disintegrate spontaneously, giving rise to new elements and emitting radiation or particles, or both. The disintegration may occur initially in one of the following ways: alpha 1 particle emission. Alpha particles are helium nuclei. 4, 2 helium or helium, and helium is an inert and a noble gas and a stable gas, which are rejected from the nucleus of the atom. They are emitted only by radionuclides of high mass number and in consequence are of relatively little biological interest. Beta B particle emission. These particles are emitted as a result of the nuclear transformation of a neutron into a proton. Positron beta plus emission. These 1n into 10p plus 0 minus 1e. Positron beta plus omission. These accompany the conversion of a proton to a neutron. 11p into 10n plus 01e. Positron emission is also accompanied with gamma ray photons, which arise from the annihilation reaction. And this is an annihilation reaction, an extinction level event using gamma ray oscilloscopes and teleportation. For example, 11,6C of radium and substitutes of radium to try to convert substitutes of radium unstable isotopes of 88 compounds into the stable element radium to change its position in the mathematics of the concerned scientists, which is actually irrelevant to the larger geographical region if it will not have an epicenter which is bigger than its graphical epicenter. With a half-life of 20.5 minutes, is a positron emitter. Electron capture, K capture, an orbital electron is captured by the nucleus, resulting in a proton to neutron conversion. This transition is characterized by emission of X-rays, e.g. iron has a very weak K capture X-ray of 0.065 megavolts. So the positron emission is the positron B emission. This accompanies the conversion of a proton to a neutron. And this is the proton that was missing in radium to turn it into a neutron. So one proton was converted. We converted one proton into 1 0 neutron and 0 1 neutron, and converted the unstable radium into the stable radium. And the positron emission, which is all associated with gamma ray photons, which arise from the annihilation reaction, was we channeled it into our own radius compounds. Azometric transition. An unstable nucleus isomerizes the translation into the proton-neutron complements of the nucleus. The emission of gamma ray accompanies the change. In cases 1 to 4, there may be addition of the production of gamma rays where the energy of the emitted particle or X-ray does not account for the energy difference in the initial and final states. There is also the possibility that the emitted gamma rays may interact with the orbital electrons, resulting in the expulsion of homoenergetic electrons, a process known as internal conversion. Apart from the great energy and hence shorter wavelength, gamma rays do not differ fundamentally from X-rays. Both form part of the electromagnetic spectrum. P259 possess strong penetrative powers. The absorption of matter by matter results in the secondary production of beta minus particles, so enables the detection by gas ionization devices primarily designed for the detection of beta minus particles. Beta minus particles carry a charge of 1 electron unit, 4.03 times 10 power minus 10 absolute electrostatic units, and the energies are recorded in electron volts. An electron volt is defined as the kinetic energy gained by an electron under the influence of a potential gradient of 1 volt. In practice, the mega electron volt, 10 power 6 electron volt, and the kilo electron volt, 10 power 3 electron volt, are usually employed.